It's a big town. And I'd like to present it a little differently and go backwards. Some of you who were in the Visual conference saw a version of this. Oh, I pointed at this.
You can use the space bar on the computer.
Okay. Now, since 1987, I've been studying periods in seismic activity. And I've reviewed over 200 papers that show positive correlations between either seismic activity, either earthquakes or volcanism, and either lunar cycles or solar activity cycles. And I have 3 boxes here. And there are 2 boxes here. And you can see the size of the literature that's being ignored by mainstream seismologists. Now, usually if you mention lunar cycles and earthquakes, somebody's going to say, oh, that's tidal trigger. And that's going to explain it. There's really a very weak correlation between either earth tidal stresses or oceanic tidal stresses and seismic activity. There are some places where you get a fairly weak correlation, but they do it by adding a phase to it. And the phase is usually completely unrealistic. One of the Jim Berkman does a lot of, he uses a tidal model, he predicts earthquakes in California, and his predictions have nothing to do with his model. He adds a phase to it. And quite often the phase is that the earthquake would precede the maximum tide by 3.5 days. That's his most common phase. And how can you have, you know, how does the effect precede the trigger? Now you do see correlations with long-term periods. And you can interpret them as tidal cycles. Some of these periods really aren't very strong when it comes to tides. Some are strong and they don't show much of a correlation. Now what I'm going to talk about is what is observed in global samples. The strongest data you have is for the long period. Decade periods. Now, this data was taken by Richard Scholars, and this is for small volcanic eruptions. This is for larger volcanic eruptions. And he gets a spike at 9.5 years for, you know, small volcanic eruptions. It didn't happen every 9.5 years. Major ones, he gets 10.8. Now, Ray yesterday told us about the foundation for the study of cycles. And I was their physical science director for a couple months. I worked with them on and off for about 4 years, and I actually got paid for about 15 months. So I did have a lot of time to go through their archives and study what cycles there were there. And what they did is that when that somebody alleged a particular cycle and some variable, they wrote it on a card and they had boxes and boxes of these index cards. I went through every last one of them while I worked there. And many of them were very weak. You looked at the data behind them, what they had. They're really, most of them weren't reproducible. But what you did get was two spikes. Most of them, like if you just looked at my volume of the cards, you had this many cards for periods like between 0 and 5 years. You know, that many for the next couple of years. And when you got the 9.5, 9.25 to 9.6, it was like that. And then around what's equivalent to the sunspot cycle, you got a lot more. That was like that. And your other periods weren't that significant at all. I think most of the cycles they saw could be explained by these two terms. By the way, this is a power spectrum, not a Fourier transform, if you know the difference. And he did all his data after like Heimlich cycles. Now, these two are fairly close together, so they will be in phase every once in a while, a period somewhere between 50 and 80 years. And then they'll be out of phase. And neither one of them, if you look at seismic activity as a function of time, and you look through these cycles, neither one of them are a nice linear cycle. They're not nice cycles. They're very irregular. So you can end up getting all these other periods. Of course, well, you have two that are periods that are fairly close together. And they produce an irregular pattern. And I really think the key to understanding cycles are these two. And that, to get back to something Ray was saying, I ignored all the economic cycles. Everything in the financial market, I just ignored it. Because there's so many driving things there. You have the election cycle, everybody lowers interest rates before a 4-year election.
Martin.
Yes.
Behind you.
Oh! Hey. And he got a spike at 2.8 years, and that's identical to the main spike that C. Castagnoli found in solar activity. This has been the enigma for a big chunk of my life. That's what I was looking at. My first attempt at explanation, some of you might be familiar with that, is that earth tides would have a different effect on expansion tectonics. If the earth was expanding, it would respond differently to earth tides than a plate tectonic model. And that had limited success. A decreasing radius, a contracting earth also has some limited success there. It turns out that one thing that does tend to be minimized there is that a lot of people think you're going to get an earthquake when the tides are at their maximum or minimum. One of the spikes you see in earthquakes is when the earth most closely resembles a sphere. The earth tides tend to cancel the most. And you're trying to fit all the continents on the small surface area. That's where you get a real increase in seismic activity. But there's one problem with that model. I have to throw one term out of the earth tidal formula. That's the anomalous Well, if I tried to predict seismic activity with an Earth expansion model being triggered by Earth tides, I'll get this peak. And another way I can tend to amplify this peak. There's another peak in there I should see about 8.8 years, which I don't. So now I'll get back what I now think is the explanation. About 3 years ago, I guess, Hector is editing a book, Should the Laws of Gravitation Be Reconsidered? And he asked me to go over the English on some of the papers. So I ended up reading these in much more detail than I would normally read a paper. And I think we were in a hurry then, if I remember right. And I think the paper was by D. Lovi. I'm probably mispronouncing his name. And he was looking at what's referred to as the general Elias effect. And I can remember where I was when I read it because all these bells started ringing in my head. It just seemed this is what we were looking at. Now, that's right, yeah. Well, we're still talking about earthquake periods. This is the same area. This is the same study with the area around 9.5 years and 10.8 years blown up. And you can see they're very definite spikes. These also occur in sunspot cycles. Whether people have found them in sunspot cycles, there's definitely a link between solar activity and seismic activity. Now this is a completely different study. It was done by Wayne Hamilton. And he just tried to fit a 19-year cycle of volcanic eruptions. And he gets 2 peaks around 9.5 years apart. It's a different type of study, and the period still shows up there.
Sorry.
What did you? Wanted to ask a question?
No, I'm fine. Unless you want to use the laser pointer.
I'm getting mixed up enough with all these buttons.
You can just use the left and right arrows on the
This is
keyboard.
beginning now.
Okay. I'm going to give. Well, yesterday I talked about some gravitational anomalies. Here we'll talk about a few more. And we'll get into what's better known as the Elias eclipse effect and then I'm going to talk about the general Elias effect and why you would find this cycle in the general Elias effect. The Elias eclipse effect is generally described as anomalous pendulum motions, pointer motions during eclipses. Some people find it very reliably, some people don't find it during an eclipse. The general Elias effect is something that occurs every day, and you get, to a lesser extent, the same type of motion, anomalous motion on the solar day, the lunar day, the lunar sidereal period, and a lunar half-year period. Now, I first became acquainted with this when I looked at cycles. One of the people who was very much involved with it at the time, John Bagby, he corresponded with Elias. And for years he tried to convince me this is what was happening. Something like that. We spent a lot of time looking at Dayton Miller's. Familiar with the Dayton Miller?
Yeah.
It's sort of a subcult of NPA. People go back and keep realizing Dayton Miller did the Lagos and Morley experiment for several years running, and there were all these anomalies. And they tend to correlate with the periods that are found in the general Elias effect. And our own Glenn Dean, who passed away recently, independently looked at the Dayton Miller data and found the same periods. I met him at the 2000 meeting. And it was one of those things that kind of reinforced my desire to kind of look at this in more detail. Okay, this is an illustration by Phil McKenna. Elias used a paraconical pendulum. Now, other people have found the same effect with other different types of pendulums. Essentially, the pendulum should precede. There's a precession counterclockwise, or there's a decrease in the precession that's clockwise. Essentially, there's some kind of torque affecting the pendulum that would be in the opposite direction. And sometime after the eclipse then returns to the original orientation, to the original precession. Now, the general effect, you get the same pattern, but this would occur as the position in the Earth either approaches right under the sun or right under the moon, or approaches a particular position in space. And then it returns as you tend to leave that position in space, or leave your position under the moon or the sun. This is what I already said. I was interested in the Elias eclipse effect. There are some places on the Earth where you get a very strong correlation between eclipses and earthquakes. There's one area in Southern California which tends to go right prior to an eclipse. It was one of the first areas I investigated. There aren't that many like that, but there's, and it is an area which tends to be on a plate. You would get a compression in that area if the plate was the North American plate turns slightly counterclockwise, which is what the Elias effect would predict. The Elias eclipse effect would predict before an eclipse. But when I discovered that, I got all excited. I wanted to tell everybody, but I realized very quickly that astrologer in Southern California already figured it out and already told everybody. I already talked about what the general Elias effect was. Yeah, and these are the periods tend to be found in the general Elias effect. They're summarized in the D. Lowley article in Hector's book. And he refers to all the data taken. Bagby also came up with something like that with different data. Now, if you try to look at what period these would be in phasing, they would, act and interact with each other. You look at their different periods. Look to see when they were in phase. And they were in phase every 9.5 years. Now, there's something I want to point out here. Could this be the result of tidal trigger? Because some of these terms here do exist in tides. At most latitudes, the main term you're going to get in tide is the anomalistic month. It's very significant. It's the distance between the Earth and the moon. The sidereal term, the first time somebody told me they found that in earthquake samples, I laughed at them. I laughed at them. With the position of the moon at a certain place in space affect an earthquake. And it turns out that's one of the ones that's the best data for it. And that is a weak tidal term, the sidereal term. So what you're seeing here is periods in the position of the moon that have that can be found in tidal formulas, but they aren't strong formulas or strong terms in the formula. Okay, so I talked out of turn. I don't want to waste any time today. Now, who wants to go next? We're already out of it. Hector, do you want to go next? Or you're ready to go?
Anytime you want.
Okay. So,
Can I interrupt for a second?
sure.
I just want to know, was there anybody last night who, yesterday, who did not sign their name for the banquet?
I did not.
What page is that?
Yes. You didn't?
Oh, no.
Oh, you did? Okay, those? Huh?
I did it on the internet.
You did on the internet, right?
Yes,
But
I
Jim,
did.
we need it on the paper, right?
But just count.
So the first break will take care of that, I guess?
First break, yes,
Yeah.
please. Okay,
Yeah,
thanks.
okay, you have the first break here.
Okay, so you're ready to go?
I'm
We got it.